Okay, so y'all wrote holiday for Monday, no, sorry, sub, Tuesday, Wednesday. So we are gonna do a quick review on quadratics. This is stuff we should have done, and we did do before I left, before the break, last 9 weeks, last semester, okay? But you should be able to take an equation like this and get a table from it using your calculator, right? So let's go ahead and first pull this up. Okay, so y'all know how to get to a new document here. So you press on, you got your calculator, new document number 1, don't save. Number 2 is to add a graph. Can you type in x minus 5 squared plus 4? So we're gonna hit parentheses, x minus 5 parentheses squared plus 4. Okay, hit enter. You can see part of the graph over there. And now we want to get the table, so we're going to press Control T. Control T. So the numbers you see there, that's fine. Just going to write our little table real quick. So X and Y, we can do like 4 numbers here. 20, 20, 13, 8, 5. And that's good enough, okay? So is everyone here able to get a table and write a table? Okay, because you're gonna have to do that on what we're doing today. So let me pass this out. Record. Yeah. Okay, so our notes. All right, here we go. So you put your name on that and everything. First things first, on example 1, it's kind of like the warm-up, but what we're doing is the parent function, okay? So remember, f of x equals x squared is the parent function, okay? So we want to fill this table in. So let's go ahead and do that. We're going to go to our calculator and type in x squared. So new document, don't save. Number 2, x squared. Control T for my table. Now notice over here, the first number they want is -2. Do you see how when you do this, it starts off at 1? You have to go up to -2. Okay, so I'm going up. And now these are the points that I'm going to put into this table. So next to -2, we have 4. Next to -1, we have 1, 0, 1, and 4. Okay? Can you take those points and plot them on that graph to sketch the function? So let's do that. -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. Oop. And what you want to do is draw through it. At the bottom, it is not pointy. It's supposed to round out. But I'm having trouble doing this freehand. All right, that's pretty rough, but that's what I got. Okay. Now the question is, how does this graph differ from a linear straight line? So linear looks like this. How is that different? What's the big difference? Curves And then the other one I'll say is direction. So you notice how direction. You notice how linear starts low, goes high, but quadratic starts high and then ends high. Like it just circles back. So quadratic changes directions, whereas linear is only going one direction. Okay. Let's do example 2. Same idea. Can you type in x squared minus 4 into your calculator? Now, if you press Control T, it gets rid of the table, hit Tab, and you go up, you can actually modify your original one. X squared minus 4 is here. And again, Control T, or the table. And I need to go up to -2. All right, and I can write these in. So 0, -3, -4, -3, and 0. All right. And then we're going to plot those again. So -2, 0, -1, -3, 0, -4, 1, -3, 2, 0. Alrighty. Cool. All right. So what is a quadratic function? So it says the previous two problems are two examples of quadratic functions. A quadratic function is a function. So we're on the back page. Sorry, flip it over. Quadratic function is a function of the form ax squared plus bx plus c. So this is quadratic. Remember, linear is mx plus b. Okay, all quadratic functions must contain what? What is unique about this quadratic that is not in this linear? What you think is in the quadratic that's not in the linear? What? So it's not, okay, the power 2, which is called the squared. The squared on the x makes it quadratic, okay? Linear will never have a squared, otherwise it won't be linear, okay? So it must contain the squared, which looks like this, a little 2. Okay. Now, what are the key properties of a quadratic? The blank of a quadratic function is the point which it changes direction. What do you call this point where it changes direction either at the top or at the bottom? What? A vortex? Oh, a vertex. Yeah. A vertex. Y'all remember that word? You write this down? Vertex is where it changes directions. It's like the bottom or the top of a quadratic. Now, there's a special name for the quadratic. We'll get to that. The blank is a point where the quadratic intersects the y-axis. What do we call that? The y-intercept is correct. What about if it crosses the x-axis? X-intercept is right. Now, y'all remember that one day I was like really annoying? Don't say today. But it was that one day, and we were talking about the other 3 names of an x-intercept, and everybody said one. So see if you remember that day. What's another name for an x-intercept? Root is correct. Not slope, x-intercepts, root, not domain. X-intercept, we already said that. Root. Zero and solution. Does that sound familiar? Okay, we went over that. Everyone said one. It was a great day. We had a pizza party. You weren't there? No, but like that one, the other time though. That's probably that one day you were absent. I gave everyone brownies. You weren't there for brownies? You want one? We're here. I got you again? Dang, that was good. All right, tomorrow I'll bring brownies. Oh, you're right. Catching on. All right, so in graph, the quadratic function forms the shape of a what? What do you call that thing, that shape? Starts with a P. Parabola. Does that sound somewhat familiar to anybody? No? All right. Parabola is that U shape, okay? So quadratic is the function. Parabola is the shape that it makes, okay? Now, you got to be able to do key features. Look at this graph. What's the vertex? What is the coordinates of this vertex right here? Okay, 0, -9, x before y. Where does it cross the y-axis? 0, -9. So the vertex is on the y-axis, so it happens to be the same number, but it's not always the same, okay? What about the x-intercept? Okay, this point right here is at -3 on the x, 0 on the y, -3, 0. That's just one of them. So the other one is over here at 3, 0. Do you see how there's two x-intercepts? What's another name for an x-intercept? Zeros, roots, solutions. Okay. Now, this is where I want everyone to pay close attention. Domain and range. Do you see how this parabola goes forever to the left, forever to the right? Domain is horizontal. It's x values from the left to the right. So if it goes forever left to forever right, we can do that like this. Parentheses, -infinity, comma, infinity, parentheses. So the infinity is like a sideways 8. Okay. So it's from -infinity to +infinity. You have to use parentheses because it does not touch a number. It just keeps going. But the range is which direction? Kind of. So I wouldn't say up and down. I would say from bottom to top. Because you don't want to start at the top. Always do least to greatest. So how far down does this go? What is this y value at the bottom? -9. And it touches -9. So we're going to use a bracket, -9. And it goes up forever. So that would be infinity. The lemniscate. That's the name of that symbol. The what? Like this one? Not that one? Not the one in Nimitz? Like this one? Oh, yeah. All right, I'm going to pass out the assignment. You got today. You'll have some time tomorrow too. But also tomorrow, I'm going to give you an updated grade and let some of y'all retake that quiz. But I'm going to pass it out. Here we go.